Hey everyone, this is Lucas Ellett, and I'm going to show you how to calculate reactions. And this is particular and for chapter 2 for you guys, because you're going to need to calculate reactions both for the method of joints and method of sections. And if you don't know how to do the reactions, it's hard to go on to joints and sections. So this will help you guys. So this is the problem that we're given right here. And we're going to find the support reactions. So there's going to be 2 reactions here at this pin support and 1 reaction at this roller support. So I'm going to move on to the solution. And here's step 1, is draw the free body diagram. So you're going to include the forces, this 5 kips to the right, 10 kips down at B, right there. You're going to include the distances that are given. And then you're going to draw 2 reactions at A and 1 at C. Now it doesn't matter if you draw them, going up at A or going down. Whatever direction you write, doesn't matter, you'll get the right answer in the end as long as you follow the correct steps. I just like to draw it so A, or the verticals are always going up, horizontals are always going to the right. But you can do it however you want, as long as you're consistent through the problem. So I'm going to move on to how to calculate these reactions after you drew the free body diagram. So we're given 3 formulas. Fx equals 0, Fy equals 0, and the moment is equal to 0, where moment is force times distance. And it's important to remember with this formula is that the distance is always perpendicular. So if we're going to take the moment about A, this distance and this force have to make a right angle with each other. And that's the distance you're going to use. So I'm going to start by finding RCV, and you do that by taking the moment about A. So when you take the moment of A, it will cancel out RAV and RAH because their perpendicular distance is 0 because they're passing through the point. So this is what it looks like. You're going to have a negative 10 kips because anything that rotates counterclockwise is positive. So from A's perspective, 10 kips rotates this way, and it's going to be negative. It's going to be multiplied by its perpendicular distance, which is 8 feet. And then moving on to this 5 kips, it's going to the right. But it rotates this way, which is also negative, times 10 feet, because its perpendicular distance is there, 10 feet. And then the last force is this RCV. And I'm saying it's going up, so it rotates this way, which is positive. And its distance is 24 feet, 16 plus 8. And that's all set equal to 0. Now you would include these 2 reactions, but again, their distance is 0, so anything multiplied by 0 is 0. So moving on through algebra, this is how you're going to calculate it. So you're going to have this 24 feet times RCV, a negative 80 kip foot, that's kips times feet, minus a 50 kip foot. So you're going to calculate that up to this. You're going to get a positive 5.42 kips in the upward direction, and it's positive. Okay. Now moving on to the next one. Let's see. So to find RAV, which is here, to find this one, you can either take the moment about C, which I prefer to do, or you can use this formula, f of y equals 0. Either one, you'll still get the right answer. I prefer to do moment. Let's see. And I prefer to use moment because 1, you get more practice with moment, and 2, you'll check yourself, so you'll make sure that you get the right answer. But I solve both for you guys. Either f of y equals 0 or the moment about c equals 0 to find RAV. And either way you do it, again, you'll get the right answer. So I'm going to start with the moment about c. So you've got your 10 kips times 16 feet. And this 10 kips, from this perspective, moment's perspective about c, it rotates positively, rotates this way, times that 16 feet. You're going to have a 5 kips that rotates this way. And it's negative again. And its perpendicular distance is 10. And you're going to have RAV, rotates this way. So it's going to be negative also. And you're going to have RAH, but since it passes through RCV, it's 0, because its perpendicular distance is 0. So that's what it looks like. 10 kips times 16 feet, then negative 5 kips, and RAV. I'm sorry. That's supposed to be negative? Yes, that is supposed to be negative. Alright, I did it right down here. Okay. So that's what it looks like. You do algebra, you get this to be negative 50 kips. This is positive 160 kip foot. You calculate it out, you get 4.58 kips. You could use f of y as well. So you just add everything in the y direction, where everything moving upwards is positive. So you have RAV, RCV, and a negative 10 kips. Again, that's this RAV, positive, RCV is positive, and a negative 10 kips going downwards. And using RCV, which you calculated earlier, to be positive 5.42, is right here. So you get a 4.58 kips, either way you do it. I prefer to use this way. Okay. Now for RAH. You're going to use f of x equals 0. So here's what it looks like. I'm saying everything to the right is positive, and you're adding up all the forces in the x direction. That's what this means. So you're going to have RAH to the right and a positive 5 kips. But my first answer came out to RAH is equal to negative 5 kips to the right. So what does that mean? I wrote a side note here for you guys. So a negative answer always means that your assumption was wrong, because there's no such thing as a negative force. So here was my assumption. I'm saying it goes to the right, but because we got a negative answer, that means this arrow was wrong, and it's really going to the left. So I wrote that here. This 5 kips is really going to the left, and it's positive. And because this assumption was wrong and we had to redraw this arrow, I corrected the free body diagram to account for that change in arrow, and that will be your final answer.